Reactive programming is a programming style focused on building software applications that handle sequences of events over time. In other words, it deals with asynchronous data streams and reacts to changes dynamically. This concept was introduced in 1997 and gained popularity with the creation of the Reactive Manifesto in 2014, which defined tenets for designing the architecture of reactive systems. Reactive programming is widely used in scenarios including real-time web applications, the Internet of Things, microservices, distributed systems, and web development. The ReactiveX API is supported by popular programming languages such as JavaScript, Python, Java, C#, Scala, and more. Several languages also support reactive libraries to build applications. RxJS for JavaScript, RxJava for Java, Reactive Swift for Swift, and reactive extensions for .NET. What are the main elements of reactive programming? Let's go to the demo. Welcome everyone. Today we will learn how to apply the reactive programming principles using RxJS, a JavaScript library. So for this demo, I'll use StatBliss Playground, applying RxJS operators and functions. So let me get rid of this sample code. The first concept that I want to introduce is the data string element, that is the core element from reactive programming that represents the sequence of events occurring over time from asynchronous operations. In this case, let me add a constant called clicks to get click events from this RxJS function by passing the document as an argument and the event name, that is click. Okay, so add the front event from RxJS. Okay, so clicks are the data streams from our application. The second element is the observable. The observable, let me add a constant, is based on the clicks observable and use the pipe function to apply one or multiple operators. So the observable represents the data stream object, the model object that is used to manipulate the data streams and subscribe to them at any given time. The third element is an operator. An operator is a higher order function that manipulates and transforms these data streams in different ways. The first operator that I want to use is the scan operator to transform the response, in this case the click event, to the number of clicks that the application is receiving by emitting values from the observable. With the scan we can transform the response and use an reduce function to count the number of clicks emitted over time. So pass the count parameter and increment by 1 each time a new click is processed or is emitted from the application. The first element is 0. So here we go, we have the observable, and the last main element of reactive programming is the observer. For this demo we'll call observable that subscribe function to simulate the observer, that is the consumer, that reacts to the data stream changes by subscribing to the associated observable object that handles the data stream life cycle. So with the subscribe function we can call 3 callback functions. The first one is the next function that receives the emitted element. I'll print by console the element. The second callback function is the complete method that print, in this case, a message confirming that the emitted values from the observable has ended, calling the completed or passing the completed message through console. And the final callback function is the error as an error handling method, passing the error event and by printing the error. So save and let's see what happens. Pull up the console. Each time I'm clicking an application, a new emitted is sent from the observable, and with the subscribe method we can print the elements via the next callback function. But to see in action the complete callback function, I'll add a new operator function. Here it's important to mention the concept of higher order function. That is one of the principles of functional programming. If you want to learn about functional programming, you can check out my video. I'll put the link in the description below. Reactive programming is closely related to functional programming because it follows declarative styles by employing different operators that can change, like scan in in this case, filter, map, and combine them to transform the data stream by applying functional principles. The next operator to limit the emitted items from the observable is the take function. I want to take the first 5 emitted items, so save it. And as you can see in the output console, just 5 items are emitted, and the complete callback function is called when all the elements are emitted. So let me use more functions to transform this data stream. For instance, if I want to print even numbers, the filter operator can be used to achieve this result by verifying if the number module 2 is equal to 0. With this filter predicate or function, we can limit and print just the event numbers. Let's see, add a new operator. If you want to transform the data, for example, from number to string, with the map operator can achieve this result. Let me add a message called next event number is passing the element. Import the operator, save, and as you can see, the data string is transformed from number to string. And the final concept that I want to mention, and it's important to take into account in reactive programming, is bad pressure. Bad pressure is a concept that deals with situations when an observable emits data faster than the observer can process it. So there are some mechanisms to handle these unwanted events, such as buffering and throttling. With the throttle operator, we can see this behavior to limit the rate at which click events are emitted from the observable. With the throttle function, as you can see in the description, emits a value from the observable but ignores subsequent values for a duration determined by another observable. In this case, I will limit these subsequent events within 1 second. I just want to emit 1 value per second. To do that, in the throttle function, pass a new observable function, in this case the interval operator, to limit the click events from the observable to 1 second. So import the operator and let's see the result. Save it. I click faster. The observable emitted just 1 element. Why? Because during that period or that duration that was less than a second, the throttle limits the emitted values by 1, because during that time we're able just to emit 1 value. What are the benefits of reactive programming? Scalability. It appropriately manages asynchronous and event-driven workloads, making it suitable for handling high concurrency. Responsiveness. As one of the tenets of reactive systems, applications react to new events as soon as they occur, providing an interactive and great real-time experience. Performance. It provides better CPU usage as opposed to single-threaded execution because it has control over the time it takes to process and respond to events. Error handling. It facilitates mechanisms for handling unexpected situations consistently. It's also highly testable due to the isolation of the business logic from the side effects. And the drawbacks. Debugging. The asynchronous nature of reactive programming makes it harder to trace the data flow and determine the system's state at a given time. Memory consumption. Many data streams can be resource intensive, and memory leaks can slow down the user experience if resources aren't used efficiently. Learning curve. Reactive concepts can be initially confusing and challenging to implement in various scenarios. It's also difficult for developers accustomed to imperative paradigms rather than declarative ones. If you want to learn more, don't forget to subscribe. May the code be with you.